Our topic for today is about the concept of mole. At the end of this video, you will be able to define the concept of mole, express the number of moles in two different ways. When we go to a supermarket, we always buy things using standard values. In other words, we always take 1 kilogram of rice, 1 liter of oil, or maybe 500 milliliter of a fruit juice. Eggs are sometimes counted using dozens. 1 dozen means 12 of something. So 1 dozen of eggs is equal to 12 eggs. These standard values, kilogram, liter, milliliter, and dozen, are used in everyday life. But what if I want to measure something in terms of the number of the tiny particles present in it? Let me explain this in details for you. Looking at this pure iron, can you tell me how many iron atoms are present in this? Or looking at this glass of water, can you tell me how many water molecules are present in this? You will probably say that it's practically impossible to calculate the number of atoms or molecules in these examples. But chemistry has an answer for this as well, which brings us to the concept of mole. So what does it mean? So 1 mole of anything has 6.02 times 10 to the power 23 atoms or molecules or particles. So 1 mole of a pure iron contains 6.02 times 10 to the power 23 of iron atoms. So in general, 1 mole of a certain element or a monoatomic element contains the same number of atoms. On the other hand, 1 mole of pure water contains 6.02 times 10 to the power 23 water molecules. So in general, we can say that 1 mole of a certain compound contains 6.02 times 10 to the power 23 of molecules. So 1 mole of a substance is equal to this constant value of particles, which is equal to 6.02 times 10 to the power 23. This number of particles is referred to as Avogadro's number, denoted by capital letter N with a lower subscript A. It is named after the Italian scientist Amedeo Avogadro. The number of moles is expressed in different ways. At the microscopic level, we can use the following formula, where the number of mole denoted by small letter n is equal to the number of atoms denoted by a capital letter N divided by the Avogadro's number. At the macroscopic level, we can use the following formula, where the number of moles denoted by small letter n is equal to small letter m, which represents the mass in a gram, divided by the molar mass of this molecule or atom in a gram per mole. Let's see if you understand the concept well. A bar of chocolate contains 1.2 gram of magnesium. Given the molar mass in gram per mole for magnesium, and you have the Avogadro's number. Here, to simplify our calculation, we will use the Avogadro's number as 6 times 10 to the power 23 instead of 6.02. Determine the number of moles of magnesium present in the chocolate bar. So here in number 1, you have to calculate small letter n, which represent the number of moles for magnesium. So we will use the following formula. The number of mole for magnesium denoted by small letter n is equal to the mass of magnesium divided by the molar mass of magnesium. Now you have just to substitute the values here. So the mass of magnesium is equal to 1.2 gram, and you have the molar mass of magnesium 24 gram per mole. So you will find that the number of moles for magnesium is equal to 0.05 mole. Now calculate the number of magnesium atoms in the chocolate bar. So here in number 2, you have to calculate capital letter N, which represent the number of magnesium atoms. So we will use the following formula, where the number of moles calculated in number 1 here, it's equal to capital letter N, which represent the number of magnesium atoms, divided by Avogadro's number. So now you can say that the number of moles for magnesium atoms, it's equal to the number of mole for magnesium times Avogadro's number. So at the end, you will find that the number of magnesium atoms is equal to 3 times 10 to the power 22 atoms. So you can deduce that this chocolate bar contains 3 times 10 to the power 22 magnesium atoms. Thanks for watching.